Hello, everyone. We have Melissa now with us from JFrog. Hi, Melissa. And
Hi.
currently, she's a developer advocate for JFrog. Her goal is to use her development experience from the last 20 years, and especially her most recent DevOps experience to help improve the lives of the developers that are learning how to navigate new tools and processes in the DevOps world. She is also a co-author on a book in progress with O'Reilly that is focused on DevOps tooling for Java developers and is supposed to come out in spring 2021. Thank you again, Melissa. Over to you. And yeah, you can start now.
Thank you very much. All right. So welcome to this talk on leveling up your Java container images. I'm excited to share with you things that I've learned in the past as a developer working with containers, which of course are still very much in use, even more so today than ever. My hope is that you'll come away today with a better understanding of not only how the containers work on your system, what's happening under the covers, but a little bit of the history and what's going on with them as well, how we actually got here today. The slides and additional information will show up on jfrog.com/show notes. It'll probably be next week before they're there, but if you're interested in grabbing slides and stuff, that's where they will be. All right, thank you very much for the introduction. Yes, my name is Melissa McKay, and I am now a developer advocate with JFrog. I started in February, so I'm pretty new to this. For the past few years, I've spoken at a few different conferences, but also had a full-time job as a developer. So the more I became interested in sharing what I've learned and presenting and stuff like that, I decided it was time to make the jump to developer advocacy and be able to do a little more research, a little more deep dives into things that I was interested in. So I do come from a developer background, so everything that I share is definitely from that perspective. It's been over 20 years since I've been in the industry. Most of my experience has been in server-side development and Java, but I have worked on plenty of other languages, different types of teams, different technologies, different tool sets, all of that. The last few years, I was on a DevOps team, which was pretty overwhelming in the beginning because now there's all of these new tools and methods that you need to learn as a developer. You're no longer sitting at your desk and only coding. There are other things in your life to be concerned about. I found that out pretty quickly the first time I was put on call. So my goal is to make that whole process easier for other developers in the field that are going through that right now. All right, let's get moving. I have a ton of information to share. I have a question for you right off. How are all of you using containers today? If you are using them at all, or if you're only using them in certain circumstances. If you could throw that information into Discord, that'd be awesome, into the chat. I'm just curious to see what people say there, and you might spark some conversation. What we're going to go through today, we'll begin with a brief history to give some background context. Hopefully that part won't be too boring. There's a lot of stuff in there, but there's important milestones in the past that are important to know to understand how we got to where we are today. We'll also take a look at the container market, what's been going on there for the last few years. Then I'll dive into getting an understanding of what Docker actually is. And after that, we'll be able to talk about what a container actually is. And then we'll get into some of the container gotchas. All right, let's jump in and start learning about containers. I know right away you're wondering about this picture of bananas. And first off, this is the rebel in me. I absolutely refuse to show any more Docker containers or anything on any slides, any presentations, whatever, any shipping containers. So I chose bananas for a reason. It was actually, when I was putting together this presentation, I was thinking about and learning more about the history of containers. I was thinking about this story my grandfather would tell me. When he was young, which was back in the 20s and 30s, he would get a banana once a year on Christmas. They were pretty rare. pretty delicious for him and his family. And he and his brothers would scrape the banana off of the banana peels to make sure they got every last part that they could. They might not get another one until the next year. So it was a pretty special occasion for them. It might not be the best analogy, but I'm going to use it anyway because I enjoy it. It was a fun theme to work with. But this story is basically an analogy to how computing resources were in the 1960s and 70s. They were very limited and very expensive. And on top of that, it took forever to get anything done. Often a computer would be dedicated for a long period of time for a single task for a single user. Obviously, limits on time. Yes?
Yeah, so people are replying on the Discord channel saying how they're using containers. So people are using for like testing and test setup. Some people are using them locally. Daniel replied he's using Jib and Maven mostly. So yeah.
Excellent. That's really interesting.
Different usage.
Yeah, really interesting to know. There's a lot of uses for containers and not always all the way at the end in production, right? There's lots of other steps in between that they can be valuable.
Yeah, and for us, we use it, for us specifically, we use it for all the developer flows. So whenever you try to test it out in local for like using Compose or things like that, so you can pretty much spin up your local environment corresponding to like production, not at that scale, but the setup wise, integration wise, and then you use the Docker or anything like that.
That's excellent idea, especially for things like integration testing. If you can get some of that done on your, locally and nearer to you, that makes things go faster. Test containers are awesome to look at. If you haven't looked at test containers, or you're still trying to do, unit testing using in-memory databases only, you might want to consider doing some integration testing with test containers so that you are, it's more like your production environment.
Correct.
All right, continuing on, limits on time and resources created bottlenecks and efficiency. Just being able to share wasn't enough, and so we needed a method to share without getting in each other's way. So I'm going to start this story with Chroot. It was born in 1979, 1 year after me, during the development of the 7th edition of Unix. It was added to BSD in 1982. Being able to change the apparent root directory for a process and its children results in a bit of isolation in order to provide an environment for testing a different distribution, for example. Chroot was a great idea, solved some problems, but a lot more was needed before we got to something functional that we're using today. The jail command was introduced by FreeBSD in 2000. Jail is a little more sophisticated. It included additional features to help with isolation of file systems, users and networks, and with the ability to assign an IP address to each jail. Then in 2004, Solaris Zones brought us ahead even further. We were able to give an application full user, process, and file system space and access to system hardware. It also introduced the idea of being able to snapshot a file system, which you'll find is really important. In 2006, Google jumped in with their process containers. Those were later renamed C groups, probably a more familiar term for you, which centered around isolating and limiting the resource usage of a process. Moving right along, in 2008, C groups were merged into the Linux kernel, along with Linux namespaces. That led to IBM's development of Linux containers. So 2013 is when things got really exciting. Docker came on the scene, bringing their ability to package containers and move them from one environment to another. The same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own subcontainers. From here, we saw the use of containers and Docker specifically just absolutely explode. In 2014, we're catching up here. We're almost to today. Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. If you didn't know that Docker was using Go, now you do. I'm almost done with the history lesson. From here on, you will see tons of names of projects, organizations, specs, etc., that are all pretty confusing if you don't have a better understanding of how containers work, which is the point of this session. One more event I want to bring up. In June of 2015, this is important to know about. It'll give you some insight into some of the activity and motivations behind shifts that happened in the market. This is when the Open Container Initiative was established. This is an organization under the Linux Foundation. It includes members from many major stakeholders, including Docker, with the goal of creating open standards for container runtimes and image specification. I'll explain a little bit more about that later. Now, while all of that was happening in the container world, a couple other dates that I want you to know that are pretty Java specific. In July of 2011, Java 7 was released. Work was started on Java 8, which was released in March of 2014. So keep in mind those dates because that's important for what you do today with your Java containers. All right, let's take a look at what happened in the market. I did some hunting. I found that for the last 3 years, Sysdig, which is a company that provides a really powerful monitoring and troubleshooting tool for Linux, probably familiar to a lot of you, has put out a container report on the analysis of their users. Part of the report includes data on container runtimes that are in use. And as you can see here, in 2017, they analyzed 45,000 containers from customers. They didn't bother even putting in a graph of what types of runtimes because they were pretty much 99% Docker. In 2018, you can see twice as many containers. Now we're getting a little bit more variety. We see CoreOS on the scene, we see Mesos. So it looks like some other container runtimes might be encroaching a little bit on the Docker space. In 2019, now we're up to 2 million containers, quite a bit more. Obviously, you can see where this is going. Docker is still holding relatively strong at 79%. Notice that 18% is Containerd, but Containerd is actually a runtime that Docker is built on top of. The last 4% is Cryo, another one that became popular. Not enough data here really to determine whether Docker will stay on top in the future, but if something else is going to come out, that remains to be seen. But this data is pretty interesting, especially because of what's happening over the last few years. And also the recent announcement by Kubernetes saying that they're no longer going to support Docker, which could be scary, but they're just talking about the runtime. The default is going to be Containerd. So one thing that you may have also noticed is that Rocket OS or Rocket containers went away. When CoreOS was acquired by Red Hat in the beginning of 2018, that project kind of died. Prior to that, it had been accepted to the CNCF as an incubating project. It looked like a really promising competitor to Docker's Containerd. But since then, since the acquisition, the project went dormant, and in mid-2019, it was archived by the CNCF, and in February of this year, the project was ended. So now let's talk about what Docker is. This is a word that a lot of people use synonymously with containers, but it's actually more than that. This is key. What Docker had over other players in the container game was a focus on commoditizing a complete solution that made it easy for developers to package and deploy their applications. Once containers became easy to use, we all witnessed that explosion of tools and resources around containers, and the Docker image format rose to become the de facto standard in the market. So the stats that I showed previously from Sysdig are specific to container runtimes. And again, I'll say that terminology is important here. The runtime is just a piece of the whole package. I'll explain these pieces and parts, and you'll understand why Docker has such a strong hold. So we often find ourselves getting too far down into the nitty-gritty details that we may lose sight of the actual problem we were trying to solve. And Docker didn't do that. They figured out exactly what developers needed and were able to provide each of those things. So let's list the needs that a developer needs in order to work with containers. These are all listed in discrete features. So first and foremost, we need the container itself. Some of you might be asking about virtual machines at this point, and I'm not going to discuss VMs. It's pretty out of scope, but it's not the same thing as a container. Containers are lightweight because they share the host OS. VMs actually contain the entire OS. That's a very simplistic definition, but that's the biggest difference between VMs versus containers. There are definitely some developments happening in the VM space, but that's for another session. So the rest of this list, the rest of the things that we need an image format to define a container. We need a way to build an image of a container. We need a way to manage images. We need a way to distribute and share images. We need a way to create, launch, and run containers environments. And we need a way to manage the lifecycle of the running instances of our containers. And I didn't even get into orchestration like Kubernetes, any of that. I won't because I'm staying on the developer side. You might not get to that point. That's more at the end of the game. But this alone is plenty to prove my point. So yeah, Docker came in and they were ready with an answer for everything. You want to start using containers, you've got Docker Engine. You need an image format, well, here's the Docker image format. You need a way to build an image, you can just call Docker build. You want to manage images, you can call Docker images or Docker remove. You want to share your images or use an image from someone else, you can call Docker push, Docker pull, and there's Docker Hub, where you can store and share all of your images. If you want a way to launch, run, and manage your containers in their lifecycle, you just call Docker run, Docker stop, or Docker PS. Docker quickly succeeded in meeting all of the immediate needs that developers needed in a container-hungry market. So on top of that, the tool sets that Docker provided just made it easy for developers. This was enough for them to walk away with a tremendous part of the market share. So in our history lesson, we learned about the Open Container Initiative. Out of all of those features that I just explained, there are two that were taken up for the cause by the OCI, and those were the image format and the container runtime. Docker did quite a bit of reorganizing their code base and developing abstractions, pulling out discrete functionality, and they are a heavy contributor to the OCI. They gave the Docker v2 image spec as a basis for the OCI image spec, and they gave runc, which was contributed as a reference implementation of the OCI runtime spec. There is a website for the Open Container Initiative, and there's links to those specs if you want to learn more about those in detail. There's quite a few other container runtimes you might see out there. Containerd, obviously, in the news right now. Rocket, sorry, went away. Cryo and Kata are also interesting ones to look at. They all have various levels of features for specific use cases. And again, Containerd was contributed by Docker to the Cloud Native Computing Foundation, and it actually internally runs runc. Containerd has also been integrated into the Docker engine. It's been in use since version 1.11, and that came out in 2016, so it's been a while. The next few years are going to be really interesting to see what happens with the specs and how the OCI moves forward. There's quite a range of differing opinions about what should and should not be in the standard for a container runtime. And we're in a situation where using a runtime that just meets the requirements of the OCI spec isn't quite enough for a developer to be happy with. I've added a couple links here. They are excellent starting places to learn more about container runtimes if you're curious. It's actually where I started when I got really confused. I landed on these two. The second one by Ian Lewis, a Google Dev Advocate. The first subtitle in that blog is literally "Why are container runtimes so confusing?" And that immediately attracted me. That is a 4-part series. That blog is, and he does a really good job of succinctly explaining some of this. He goes into details about low-level and high-level runtimes as well, and does a little bit of comparison there. Pretty interesting stuff. So what if you don't want to use Docker? There's a few other things out there. The work that Docker has done to, pull out abstractions and pull out certain features and contribute stuff to the OCI, it's making the capability for other players to be able to come in. And so you're not stuck with Docker. This set of tools, Podman, Builda, and Scopio, this is backed by Red Hat pretty heavily. Podman has all of the features involved with running containers. Builda does the building of the images. And Scopio is concerned with transferring container images from remote repositories. So sit yourself down and ask yourself why you don't want to use Docker. There's probably some pretty specific reasons why. Maybe your environment, maybe your OS that you're running on, who knows? Maybe you don't want to use that long-running Docker daemon, which Podman does not use the Docker daemon. So that's maybe one thing that you would care about. Maybe you just want to stop thinking that Docker is all there is and getting tied into one product all the time. Maybe you just want to build your own images using a bash script. Builda actually allows you to use an existing Docker file, or you can build images step by step yourself from the command line. The cons for this, and a reason why I'm not using these, is just because it's not very convenient to run on my Mac or even Windows. There's not a good wrapper for this. I did find one option, Podman machine, that still requires you to set up a Linux VM on your box. So just for simplicity's sake, Docker is still a pretty valuable tool for developers on their local laptops, right? Maybe some of you have some experience with using some of these other options and have something that you can contribute to the conversation. But the other option is just don't use containers at all. I mean, after you've heard all this, maybe you just want to throw it out and not use them at all. I saw a really good presentation by Jessica Dean talking about bridge to Kubernetes. That's a way for a developer to go ahead and code and make changes. You don't have to worry about building a container or anything. You actually connect to containers that are already set up in a test environment. And then you control routing specifically so that you can get your specific code and be able to do debugging and things like that. Pretty cool. Unfortunately, it's limited to Visual Studio and VS Code. Great if that's what you use. I'm an IntelliJ gal, so I probably won't be using that until there's support for it. You also have to have your project set up just so that the routing stuff works appropriately. But anyway, something to look into if you're done with this and you just don't want to use containers at all. So what is a container? Now that we understand some of the Docker, some of what Docker entails and some of what's going on in the market, let's just focus on the container itself and just see what it looks like on your system. So my first experience with containers was basically I got put on a team and just needed to work on the project immediately and just get something up and running. So it was kind of a rush. But what I figured out is Docker images are really just a tarball of a complete file system. When an image is unpacked, it's just thrown into its own directory and that becomes its root file system. The second is that processes that are involved in running the containers are just regular Linux processes. On top of that, there are just a few Linux features that are used together in a way to achieve the isolation that we want from containers. Namespaces and C groups, obviously really important. The C groups functionality is integral to constraining how much a container can use things like CPU, memory, network, bandwidth, etc. So definitely remember that. I have an example of constraining some of my memory usage here that you can see. That's something important I'm going to bring up a little bit later when you're using Java containers as well, when you're packaging up your Java apps. So keep that in the back of your mind. I'm going to gloss over quickly some file system details. The first thing I did was figure out where everything was. After you've installed Docker, running the command docker info will spit out a bunch of information about your installation, and that includes where the Docker root directory is. This is where most everything you're going to care about regarding your Docker images and containers will be stored. If you're on a Mac, your containers are actually going to be running in a tiny VM. So you're going to need to use something like Screen to get in there and get to the Docker root directory to look around. If you're not familiar with using the screen command, do yourself a favor and Google that, because it'll mess up your text display pretty good if you don't enter and exit that appropriately. This slide shows how you can get some information about the images that are stored on your system. I listed the available images using the Docker images command. I actually have several installed, but only the first couple in the list are displayed here. I can inspect any image I like using its image ID. This spits out a ton of interesting information, but look at the graph drivers section. Docker images are composed of layers. They represent the instructions that are in the Docker file that was used to build the image originally. They translate into directories, and these layers can be shared across images in order to save space. The lower dir, merge dir, and upper dir sections, especially important. The lower dir directory contains all of the directories or layers that were used to build the original image, and these are read-only. The upper dir directory, sorry about that. The upper dir directory contains all of the content that has been modified while the container is running. If modifications are needed for a read-only layer, then that layer is copied into upper dir, where it can be written to, and that is called a copy on write operation. Very important to remember that the data in the upper dir is ephemeral data. It only lives as long as the container lives. In fact, if you have data that you intend to keep, you should utilize the volume features of Docker and mount a location that will stick around even after the container dies. And this is how most containers running a database are run, for example. Lastly, the merged dir is kind of a virtual directory. It combines everything from lower and upper dir. That's the way the union file system works, so that any edited layers that were copied into upper dir will overlay the layers in the lower dir. All right, this is just an example of a few containers that I have running on my system. Note the container IDs of the running containers match up with the containers subdirectory names. Something to remember here is if I stop a container, that corresponding directory doesn't automatically go away until the container is actually removed with the docker remove command. So if you have stopped containers lying around that never get cleaned up, you might see your available space start to dwindle. There is a docker prune command you can run that will help you clean things up. You can also launch your containers with a flag to indicate that it should be removed when it's finished running. All right, gotchas. We have 1 minute left. I think I might be going over a little bit because I really want to get through some of these gotchas that you're going to run into. These are things I ran into for sure the first time I was working with containers. The first is running the containerized application as the root user. I didn't care about this at first. I was just happy to get things up and running. But now that you know that processes inside a running container are just like any other process on the system, It's scary now to run as root inside the container. Doing that opens up the possibility of a process escaping the intended confines and gaining access to host resources. The idea here, you need to reduce the attack surface. That's a good practice whenever you're thinking of permissions and access. So use the principle of least privilege here. Containers are designed not to affect other running containers, but if someone were to gain access, they immediately have root privileges and they can wreak havoc on the host. So to mitigate this problem, create a user and use the user command inside the Docker file when the container is built in order to run the processes as that user. There is a way to specify a user when you use the Docker run command, but that leaves open the possibility of forgetting to do that. It's nice if the image is just set up by default not to run as root. And images that you get from Docker Hub, pay attention to whether they are using a user as well, or if that's something that you need to set up. No constraints. Docker provides you with the ability to set resource limits on your containers. It doesn't automatically do it for you. So the default settings, in fact, are free and clear with no limits anywhere. So make sure you understand the resource needs of your application. Too little and your container is going to die from starvation. Too much and the container will smother others on the system. The resource usage of your containers is something that you're going to want to monitor over time and adjust as needed. It's a good way to determine if something is wrong or if load on your system has changed for some reason. So never updating, pretty big security issue. It's easy to get complacent and not pay attention to what's actually getting pulled in when you build images. You need to be aware of outdated versions that you specify in your Docker file. Pay attention to base images and where they're coming from. Not updating packages and libraries inside your container can lead to some pretty embarrassing results, especially when there are a lot of tools available now to alert you when security issues have been discovered with specific artifacts. So keep up with those updates. I've been on teams where this has not been a priority, and that's primarily because of the fear of breaking a product or service that's already working, and that's a symptom of different problems. Trust me, it's much worse to leak private data or potentially be the start of some domino effect that can bring an entire system down. All right, this is specific to containerizing Java applications, very much related to being aware of what your application requires to run successfully regarding memory. In our history lesson, when I mentioned the dates for Java 7 and Java 8, remember this, the JVM is pretty clever at automatically determining settings for your swap and heap and your garbage collection behavior, but it's based on things like the memory and the number of cores available. Considering the timeline of Docker and Java releases, early versions of Java 8 are not fully container aware. If you're stuck on Java 8, you need to make sure to get those updates. I believe a good one would be like Java 8 update 131 and after. 11 is very much container aware, but things have been backported to Java 8. If you're stuck on a legacy version older than that, all is not lost. You just won't be able to depend on the JVM automatically determining the best use of resources for you. You're going to have to explicitly say that when you launch your applications. All right, image bloat. There are three main ways that this can cause you problems. If you're pulling in large parent or base images that include a bunch of stuff you don't need, obviously there's one. Another one is ignoring the Docker ignore file. Just like you have a Git ignore file, there is a Docker ignore file, and you should definitely be putting stuff in there like your .git directory. There are multiple problems here when you see Docker files that copy the entire source tree of a project, including the tests, etc. There's another problem with copying the entire source tree in one line makes one layer. That means if anything changes, that layer has to be regenerated every build. That's a waste of time. Organize your code if you can so that stuff that changes the most often is in its own layer. Maybe separate out your implementations versus your abstractions. Make sure they're in different layers so that not everything has to be regenerated all the time. Also, you could mistakenly include secrets. Pretty bad idea to just do a flat out copy of everything. Another one I see in Docker files with Java is including the build tool. I'll see a Docker file that brings in Maven, does the whole build, and then builds a jar file or whatever, and then runs it. Think about what's happening there. A container is ephemeral, right? So when you have that, if you have to rebuild, you're not going to have a cache anymore, for one thing. When you're rebuilding your image, you're going to lose all of your Maven cache. That can take a lot of time. Also, you do not need to include the build tool in your production image that you put out on production. It's just more than necessary. So take advantage of stuff like either use like a multi-stage Docker build. That is a way to go ahead and do the Maven part, but then that's not included in the final image. Another is just build outside of the container. Build your project before you build the container, so that you already have your artifact, your Java artifact. This problem is not limited to Java projects either. I see this across the board a lot with npm. I'll look in a Docker file and I'll see npm build, and it just takes extra time for you. All right, managing your images. By default, if you don't specify a repository, your images are coming from a remote repository, specifically Docker Hub. That registry is great. It's great for everyone to be able to share images there. You can get official images there. I highly encourage you, though, to write your own Java images and get yourself a container registry that you own, that is internal, that you can secure. You need reliable access to required images for your builds. Avoid those random failures in your pipeline because of network issues or just missing an image. And control access to your proprietary images. There's a lot of free tools available out there. I have to mention JFrog's free container registry. That's definitely one option. And I'm going to leave you with a couple other resources here to look at. I did write a dzone ref card on this, getting started with container registries. Really good information on why you should care and what to consider when you're setting those things up. Also, when you build your own images with the JDK, because you should get, when you get more specific on which version or update that you use, check out fuje.io. I'm a friend of OpenJDK, and it's a really good resource for comparing the differences between the Java versions and getting detailed info on updates and comparing OpenJDK vendors. Something to notice in your from line when you're bringing in an OpenJDK image, pay attention to where it's coming from. You may not know necessarily exactly what updates are included and what JDK vendor you would even go to ask questions or report a problem. All right, that's it.